All right. Hello then. My name is Ned Rossiter, and I work in the Institute for Culture and Society and the School of Humanities and Communication Arts at Western Sydney University. Welcome to this international symposium on contagion design, which I've organised with Gay Hawkins in concert with the session chairs, Brett Nielsen, Catherine Gibson, Stephen Healy, and Tony Bennett. We begin with an acknowledgement of country, and I like the way ICS colleague Tony Bennett framed this acknowledgement last week for our overseas participants, and I'll adopt some of his words here verbatim. It is a custom in organising and hosting events in Australia to acknowledge that the events and our talks today are held on colonised land that never has been and never will be ceded by its original owners. In hosting this event, the Institute for Culture and Society at Western Sydney University wishes to acknowledge and pay respect to the Darug, Eora, Darawal, Wiradjuri, and Gadigal custodians of this country, past, present, and future. ICS also supports, as Tony noted, and I thought really nicely, the Uluru Statement for the Heart, a statement that arose after an extensive consultation process conducted by Aboriginal and Torres Strait Islanders, and proposed a constitutional voice for Indigenous Australians, a proposal that the current coalition government has rejected, but it's a powerful statement that remains an active proposal and has broad support among Indigenous and non-Indigenous Australians. With regard to the format of today's session, each speaker will present for around 15 minutes with questions and discussion following all three talks. This event has been recorded. If you would not like to be recorded, please be sure to keep your video and microphone off. If you have concerns about the recording, please let me know. The recording of this event will be put online at some point pretty soon. Finally, thanks to the Institute for Culture and Society, Western Sydney University, for their support of this international symposium. And a special thanks to Elise Blight for all her Zoom and event management work, along with event promotions helped by Sally Burns and Emily Kate-Ringle-Harris. Again, the last thanks goes out to the design team at Public Office in Melbourne for bringing a visual syntax to the concepts that frame this event. I'll spend the next few minutes just giving a brief, indeed, framing of this particular session we have and introduce our speakers. Over the past 3 weeks, this series of talks has addressed how labour and migration, alternative economies, and practices of habit manifest in ways that condition and are affected by pandemic outbreaks. Today, we will consider the relation between data and contagion. For many years, computational systems have been accompanied by the cultural imaginary and technical unleashing of viruses hell-bent on destruction. If viruses distributed across communication networks and through shared devices condition the ontology of the digital, what possibilities emerge for building media theoretical concepts attentive to technical propensities and social practices of infection? Does data contagion specifically alert us to new circuits of distribution and modes of attack? In the context of the ongoing pandemic, we might probe the tendency in the field of data analytics and strains of digital media studies to fall prey to the correlation fallacy. While we can agree with Bernard Siegert's intervention that the map is the territory, that maps are generative of worlds making experience intelligible as reality, we can only do so in recognizing that territory is multiplied across innumerable cartographic articulations. Maps, in short, are not always translatable as territories. Sometimes they are just maps, a set of coordinates whose spatial relations are decoupled from power and knowledge. In other words, the correlation fallacy of data analytics mistakes the diagram of relations specific to data architectures as equivalent to a world external to these computational systems. Mapping constellations of Twitter hashtags or visualizing geographies of Google search data, for instance, will not reveal that much about the nuanced variation of material and phenomenological life external to the pervasive and always binary logic of the digital. Instead, a kind of unconscious self-referentiality haunts interface designs and claims of transparency and revelation through digital methods. Moreover, The analytical grip of correlation only holds within a protocological universe of interoperability. Once a system of communication starts to falter when signals encounter noise, the rich uncertainty of contingency enters the stage and all too often glides unseen across the bridge to technical and service areas that enable theatre of performance. We could understand such instances of contingency meddling with the order of things in terms of what Eugene Thacker ascribes to the negative immanence of contagion, or moments in which data contagion presents as asymptomatic. What then, for all those occasions in which the volatility wrought by viruses are indiscernible, in which change and transformation reside beyond thresholds of perception? Are such alien moments cocooned by the operational logic of the machine that we assume to know? Let me be clear. In describing contingency as external to the parametric horizon of the digital, I'm not searching for ontological distinctions between humans and algorithms. Such are the conceptual limits of critiques of algorithmic bias by researchers who, as Louisa Moore points out in her book Cloud Ethics, frame an accountable human subject outside algorithmic power as the locus of responsibility in the setting of normative standards, regulations, and codes of conduct. Moore opts instead for a machinic concept of subjectivity, always already enmeshed with data architectures and algorithmic arrangements. In conceiving this international symposium as contagion design, we've brought together two terms that perhaps sit in an unlikely or awkward relation, particularly the term design, which can be understood not just as an aesthetic register or style, but also as a plan, as a logic of organization underscored with intentionality. We can also think of design in ways that Stephen Healy and Declan Cush sketched out in their talk a couple of weeks ago on contagious mutuality. Design as feedback loops, recursivity, and patterns. How then, in this discussion today, might we extend these kind of attributes of design to the relation between data and contagion? These very short framing comments may have no bearing at all on how our speakers address the topic of data contagion, but at the very least, I'm certain the talks this morning will provide insights, special insights, into how we think the relation between data and contagion. So it's now my pleasure to introduce the speakers. I will just read out a short one-line bio for each of the speakers prior to their talks, and then paste a more full-length bio in the chat session there. So first up, we have Mark Andrejevic, and he is professor in the School of Media, Film and Journalism at Monash University. Thanks very much, Mark.
So I'd also like to start with acknowledgement of country and of the land where I'm speaking to you from. I'm coming to you from the unceded land of the Boon Wurrung people of the Kulin Nations, and I'd like to pay my respects to their elders past, present, and emerging, and to acknowledge any Indigenous people who might be with us today. I'd also like to start off by thanking ICS for supporting this and for the invitation, and Gay and Ned for organizing it. It's great to be here. It's a really exciting group. I really enjoy the format of this is a kind of ongoing series of events. Although I apologize, I had some conflicts missing the early one. So I'll get started. I'm gonna, usually I talk, but I'm worried about going over time when I talk. So this is a more scripted presentation. And sorry, I have in the background, you know, for your I don't know, Zoom entertainment, some visuals that I'll put up alongside. So I'm just going to share the screen on this. So really the you know, the kind of provocation for this event connected a lot with work that I'd been doing, because I have a project looking at the deployment of facial recognition technology in Australia, and you know, there was meant to be a series of you know, case studies where we could kind of go to locations and look at the deployment of the technology. This has been curtailed by pandemic events. So instead, we spent a fair amount of time going to online trade shows around the world. And it's been quite interesting looking at the deployment of biometric monitoring at a distance in response to the COVID moment. And so it's that experience of going to these different trade shows and seeing the kind of economic opportunity that is offered by the promise of being able to manage contagion via these various forms of largely passive data collecting devices that shape this notion of securing circulation. So that's the context, and I'll dive into it. In a sense, this presentation approaches what might be described as the big picture question when it comes to the prospect of the widespread deployment of facial recognition technology and other forms of biometrics at a distance. How are power relations reconfigured by the generalization of the capacity to monitor people passively at a distance in shared spaces via these biometric vectors of information collection? And I suppose that's the larger kind of framing question that I bring to this whole facial recognition project. There are, of course, numerous answers to this question, but drawing on some of the use cases that I've been studying around the deployment of facial recognition in response to the pandemic, I'm going to focus on the category of circulation and its governance. Prior to the advent of mobile network devices, when the home computer was king, the circulation of data was framed in an inverse relation to that of people. This is a familiar 90s moment for those who remember that moment. Because so much information could move so quickly, people wouldn't have to. That was the conceit. For Bill Gates, road ahead era, writing relatively early in the history of the online economy, one of the signal virtues of the internet was the ability to stay connected without leaving the privacy of home, to be alone together, as Sherry Turkle put it, in a later and more critical formulation that's since been repurposed in some of these public service campaign messages you may have seen. Stasis was, for Gates, a form of liberation from the limitations of physical mobility. If you let your bits travel for you, you could virtually roam farther and faster. And this is a quote from the road ahead. There will be a day not far distant when you'll be able to conduct business, study, explore the world and its cultures, call up any great entertainment, make friends, attend neighborhood markets without leaving your desk or armchair. This version of a form of kind of techno-liberation takes on some quite different overtones when read against the background of the recent limits on interactions, interpersonal interactions and mobility during the pandemic. Gates thought he was predicting a particular, pro-social fantasy in certain ways, and for certain, conditions. Of course, that persists. But in the wake of the pandemic, it also sounds like a kind of perpetual quarantine. Contactless culture may not seem particularly inviting when it's a function of necessity rather than choice. As even Gates noted, physical stasis curtails a swath of productive activities that rely on physical circulation. The advent of mobile network technology addressed this issue by opening up parallel avenues for virtual and physical mobility, facilitating always-on availability for work, interaction, sociality, consumption, and so on, always redoubled also in the form of monitoring and tracking. The model of physical stasis was, through the advent of mobile network devices, rapidly overturned by the more economically productive alternative of mobile networking, when apps of all kinds supported the acceleration and rationalization of circulation itself as a productive force. Enter COVID-19. The pandemic provided a stark reminder of the economic impact of stasis, at least against the background of the structures that had been set up prior to it. Restrictions on circulation coincided with the threat of an economic downturn, shops closed, airplanes grounded, venues shuttered, movement constrained. The mobilization of biometric monitoring offered a response to this perceived trade-off, along with a host of other interactive platforms, one of which we're availing ourselves of now. Circulation could be reinstated if it was coupled with comprehensive monitoring. And now I'm talking about physical circulation to track contacts, monitor adherence to social distancing and quarantine, and detect emergent symptoms. One way to think of this shift that I'm proposing is from a logics of plague and pandemic to those of endemic. Endemic logic, as Michel Foucault's repeated exploration of the relationship between disease, governance, and surveillance suggests, focuses on environmental measures, those he associates with the register of the biopolitical. Sorry, there's a fly that's attacking me. As he puts it, when focusing on endemics, the emphasis will no longer be upon the problem of exclusion, as in the case that he invokes of leprosy or of quarantine, as with the plague, but of the medical campaigns that try to halt endemic phenomena, halt and contain and control, I guess we could say. And here is where I want to suggest the promise of automated surveillance, of passive biometrics at a distance, has an important role to play in reconfiguring the set of oppositions between the individualizing and normalizing thrust of discipline and the population level approach of biopower, between operating at the level of subjectification, the internalization of uniform norms, and intervention at the level of the milieu, the rules of the game, but also articulating that to environmental modulation, the actual reconfiguration of physical environments. The types of interventions typically associated with studies of biopolitical governance, interventions at the level of infrastructure and standardized protocols for managing statistics that, while aleatory at the individual level, are normalized at the aggregate population level, fertility, morbidity, mortality, and so on. In our disaggregated, hyper-customized, mass-tailored informational economy with its attendant infrastructures, the goal is to be able to, in a sense, normalize these figures at the individual level, as witnessed the disaggregation of actuarial calculations based on portable fitness trackers or distributed Internet of Things devices that collect detailed information about individuals in order to extrapolate individual patterns of risk and threat for actuarial calculation. I think the relatively novel, although not entirely new innovation, is the articulation of biometrics at a distance with the modulation of circulation and physical space. On the one hand, biometrics at a distance addresses the problem of the device, that you need some type of a device to be able to interface with information collection systems. It bypasses the device to go get directly to the body. If environmental forms of governance rely on adjustments to the rules of the game, biometrically enhanced biopolitical interventions incorporate the reconfiguration of the physical environment. What are some of the ways in which the physical environment can itself be modulated in response to information that's collected at a distance? For example, combining facial recognition with temperature screening and mask verification in order to provide entry. Sorry, I forgot my slide about telecommuting. We're just going to skip that. This is one of the many deployments of a kind of combined facial recognition access point that also monitors temperature and adherence to hygiene protocols, in this case, wearing a face mask. So combining all of these gets associated with monitoring checkpoints and access points. One of the things that I've found spending a fair amount of time at these online biometrics trade shows in the past few months is to see how many sessions have been devoted to doors and access. One of the conferences I went to, I think, had 2 or 3 companies that were just door companies presenting their material. And this had to do with a couple of things. One, with the new imperative of touchlessness, the idea of not touching the object, and therefore, automated forms of ingress and egress. But also, of course, the ability to control access based on articulating these biometric technologies to automated forms of access. So, but the monitoring isn't simply at discrete choke points. It's not just the binary in or out, access or not. It also takes place continuously to track flows, interactions, and circulations. These systems overlay identification technologies with proximity and density monitoring. Some systems are able to incorporate symptom monitoring as well. The population can be captured at scale, or at least that's the promise, but simultaneously disaggregated in real time, right? The ability to track the overall flows, but to disaggregate it into the individual contributions. This I'm just going to kind of play in the background. It's a technology for monitoring social interaction. Whoops. Let me get my, there's no audio, but I'm just going to have it as a kind of, visual connection. The population can be captured at scale, but disaggregated in real time. The surveillance operation in this context is not primarily symbolic, that is to say disciplinary, although there are elements of this, but might be described more as operational. Certainly there's the implicit message, you're being monitored, so observe the protocols. But there's also a level of intervention that acts directly on individuals, assessing individual risk, sorting flows, controlling access, diverting and detaining. The coupling of identification and symptom monitoring at a distance with physical processes of circulation control becomes a strategic tool underwriting the imperative of maximizing the productive powers of the population and the economy, while placing differential restrictions on that same population relative to disease prevalence, risk, and proximity. The rapid pivot of a range of companies traffic in biometric monitoring technologies and facial recognition in particular, towards this pandemic management, capitalizes on the appeal of the promise to provide a technological fix for the socio-ecological complexities and disturbances brought about by contagion. The development of automated monitoring systems that operate simultaneously at the level of the population by networks for mass monitoring in real time, and the individual via smart biometric systems that can isolate and identify, rearticulates the relationship, I think, between disciplinary power and biopower. Automated systems anticipate the possibility of environmental modulation that targets individuals, and simultaneously the mobilization of disciplinary controls at the mass level, ensuring everybody is wearing the proper gear, moving in the correct way, staying within defined zones of movement and activity. Spaces can be and this seems to be also the connection to thinking about augmented reality and the malleability of physical space once it's overlaid with informational systems. But the actual reconfiguration of physical space in real time in order to sort individuals based on the biometric information and other information that can be connected to that by linking other databases with the info that comes from the surface of their bodies. In mid-July, for example, NEC, a big facial recognition, a player in facial recognition technology, launched a reorganization of its Tokyo headquarters. I'll show you their little video on that. According to the principles of what it terms the ID Light concept, which combines detailed tracking with touchless interfaces. NEC is one of the world's largest biometric firms, and it uses its own office to showcase these systems. It frames these systems as technologies that enable employees to optimize their physical movements throughout the day through, for example, touchless touch points for entering, for purchasing, touchless temperature scanning for symptom monitoring. The ideal NEC workers' movements are choreographed. This is the connection to Gay, I think there's a lot of connection to Gay's paper on this, such that essentially the only actual point of contact she has is with her laptop. Which also uses biometric identification in place of old-fashioned password protections, ensuring that her working day is frictionless, secure, and personalized. That's the quote. Of course, there are harder edge instantiations of the technology, the use by law enforcement to scan crowds for quarantine violators, the access of driver's license databases by Clearview AI and the FBI in the United States, apparently for the purposes of identifying undocumented people at a distance in crowds. A policing of circulation that kind of marks the border on the body. This use by the FBI is an unanticipated consequence of the decision by some states in a ostensibly progressive move to provide driver's license to undocumented residents. But that undocumented status, of course, is attached to the license, which is then in turn attached to the photo. The border starts to travel with the face. The monitoring is not just at checkpoints, but throughout flows of circulation. There are also a range of commercial applications that replicate the familiar convergence between securitization and commodification, risk and profit. For example, the deployment of biometrics at a distance in stadiums, which is another one of the use cases that comes up over and over again in the trade shows, operates not just to detect possible troublemakers based on image databases, but to sort flows of entrants and consumers, redirecting VIP guests to speedier queues and premium services. coupled with machine learning systems, smart cameras can both risk and opportunity. So it's not just the identificatory information that they're collecting, it's also looking at patterns of interaction and patterns of behavior in order to generate lists that the trade literature calls white and black lists, lists of both opportunity and risk. And modulating circulation in real time, preventing access, diverting flows, sequestering particular spaces. One of the challenges posed by ubiquitous biometrics at a distance is the mobility of cameras to keep pace with circulation. Thus, a range of solutions are being proposed and implemented, including the dronification of smart cameras, drone swarms that are equipped with facial recognition technology, the deployment of walking security cameras, human authorities equipped with biometric smart glasses, or rapidly deployed to comb through crowds and pull out those who've been determined to be symptomatic based on remote biometrics. NEC has a program like this that it's implementing in airports. Facial recognition that captures, as people move through the airport space, temperature, and then sends messages to roaming folks who go through the crowd and just pull out the people who have been detected to have elevated temperatures. Linking these deployments together is the combined logic of what I've described as framelessness, continuous ubiquitous monitoring, preemption, assessing risk at an individual and granular level in real time in order to intervene based on correlational predictions. So, not just pull out the people who have symptoms, but also identify, isolate, and redirect the flow of those who have demonstrated evidence of risk. Granular environmentality. And what I mean by that is the reconfiguration of spatial affordances at an individual level, the actual reconfiguration of space, and operationalism, the collection of data that acts in a chain of operations rather than merely representing, rather than really saying, we can now measure levels in a population, but actually we can act on that population, we can intervene through the environment. What's been intriguing about the fieldwork around this, I think, is that whereas political discourses gestured toward the return to normality, heralded by the promise of designing risk out of circulation, this is the message we receive over and over. Return to normalcy. If you adopt this device, use this technology, it will get us back. The industry perspective is completely different. It's of a new normal, one that's generalizable across a range of risk and opportunities. It's not that this is some exceptional moment. It's that this is an opportunity to shift the whole operation of the apparatus in ways that can address future risks, future opportunities, for which COVID serves as both a catalyst and a wake-up call.
Sorry,
That's
Mark, we're coming up to...
I'm done.
Oh, wonderful. Great.
Okay.
Super, thanks a lot. We'll now just move directly to Rolien Hoyng's talk. And Rolien is assistant professor in the School of Journalism and Communication at Chinese University of Hong Kong. Thanks a lot, Rolien.
Hi everyone. Thanks for coming and thanks for the organizers organizing this wonderful series. Let me start sharing. All right. Okay. All right, so I'll talk about AI and contingency in circular economies. And my take on the theme is not as much directly connected to the pandemic, but I think there's a lot of overlap and connection to what Ned said in his introduction. So I'll start out by taking you on a little balloon ride. This is balloons from the public lab that have a little camera attached to them. And I used this when I was obsessed with trying to see electronic waste. I wanted to see it. And these are the images that we got taken in Hong Kong, where I'm based. So I'll just have this run for a little bit. Now, I'm going to talk about how AI, artificial intelligence, is fitting into the seeing of waste, the sensing of waste, the touching of waste, and recycling. AI promises to enhance repurposing of waste so that so-called circular economies become possible. For the electronics industry, this implies that the continuous innovation and committed consumption, critically referred to as planned obsolescence, would no longer pose a threat to ecological survival. Against the degrowth mantra of environmentalists, the corpus discourse on the circular economy holds that growth of both of markets and continuous product renewal go hand in hand with sustainability. For instance, Apple claims that they take less and less from the Earth's resources because they're able to support their production through recycling. According to the Ellen MacArthur Foundation, a key actor in this scene, there are still many questions left regarding how to use AI, but supposedly it ensures that e-waste no longer, so electronic waste, no longer forms an unknowable, valueless, purposeless mass, but is indexed, surveilled, calculated, forecasted, and as such managed. This paper discusses the AI-enabled circular economy of consumer electronics, and it compares such formal processes to informal recycling that lacks documentation and may be part of illegal economies. I theorized the intersection between twin components. 1, waste matters potential. 2, AI technologies of sensing and monitoring. And I want to make here a little disclaimer in this paper. I don't really look at specific technologies. I've done that in another paper that I published before. And the third component is data-centric aesthetics articulating transparency and rhetorics of corporate responsibility. The comparison between formal and informal recycling industries offers us a chance to reflect on responsibility at the times that AI-enabled logistics shape ecological ethics and interventions. How do the informational changes re-articulate conventional political notions of transparency and responsibility? And how do they impact the boundary between formal and informal operation? What are the ambivalences of the formal and informal circular economies of electronics when data materialities and waste materialities affect one another? Okay, so the Ellen MacArthur Foundation claims that truly circular economies cannot exist without the Internet of Things. To be sustainable, a system must be responsive and actions and behaviors must be connected via data and knowledge. That's what they argue. AI works here, or is imagined to work as an, and I quote Masumi, iterative practice of making in the face of the uncertain and the unknown. Which here then refers to waste as an amorphous contingency with potential that is open-ended, which means that waste can become anything from a refurbished item to a new product or toxic hazard, depending on what kinds of relations it enters into. That is to say, recursive feedback loops function to combat contingency, not by eliminating or ignoring it, but by integrating it. Contingency could be catastrophic if a system does not know how to react to it. But the feedback loop of these systems allow for contingency to be re-articulated as possibility or probability, drawing on Yukhu here. AI applications act as operators of potentialities, quoting Parisi. So they exert control over these potentialities to manage them. A perfectly AI-driven circular economy would register, monitor, and secure all waste and waste flows in such a way that data subsumes matter and reduces it to code in order to shape the matter and exert control at the expense of material agency and potentiality. Control forms a formative and anti-tropic type of power that renders sculpted materiality in which that renders sculpted materiality in which vital agents are managed, organized, and affected. Quoting here a notion of control from Galloway. Following the discourse of the circular economy, waste matter should never remain simply waste. Even there's no waste at all, only products to be. Such discourse engages the logic of preemption, that Mark also referred to, in that possible futures determine action in the present and hence inform the continuous modulation of present states. Preemption involves a particular type of agency, responsibility. So I'm now not saying responsibility as in corporate responsibility, but the ability to respond, that in my case coincides with corporate responsibility. The AI apparatus of the circular economy deals with contingency and indeterminacy in the interest of preserving some kind of order that I call the ontology of delimitation. The etymology of formal as an objective goes back to the 14th century and refers to form or arrangement and also the essence of a thing. In e-waste recycling, this etymology can be helpful to characterize the formal sector's endeavor to inform, as in imposing formal matter and giving form and giving shape to matter, reflecting a presumed order of things. The ontology of delimitation articulates with moral discourse, capitalist property regimes, and legal orders. Hence, we have an ontology of classified, specific, determinate items, models, and brands, a binary scheme of functionality and breakdown. It either works or it's broken, and a corporate identity inscribed with legal formality that comes across as the brand as an interface, and that authenticates and guards this ontology. The endeavor of the formal circular economy does not only target research use reduction, but also aims to undercut informal circuits. Informality can be characterized by the lack of information about what things are, and opacity with regard to practices and processes which threaten this ontology that I have described above. So here you see some informality goes without too much data sorting and classification. There's unsorted of roughly sorted stock and lack of a detailed inventory. Bulk sales often mix working devices and not working ones. The lack of data that informs an order of things is reflected in display methods, in the informal circuit of street markets and heaps of unsorted, hardly extracted cables, different devices or brands, or even electronic items mixed up with magazines, broken toys, and watches. And such display methods reflect an indeterminate ontology, whereby what something is ultimately depends on the potential a passerby or trader sees in it, and hence it is a relational question. The formal sector offers corporate transparency, yet simultaneously technomaterialities remain black boxed and literally sealed off with a warranty seal. By contrast, the informal sector entails opacity in terms of its operations, but combines this with openness in the material relations between humans and technology, enabling more spontaneous processes of becoming. Moreover, corporate responsibility articulates the corporation as the central actor, whereas the informal circuit distributes the ability to respond. Now, I have to also put a disclaimer here. I'm drawing on a particular understanding and particular aspect of informality. It's not all of the informal sector. However, the formal circular economy is not exactly centralized if we consider the supporting AI technologies. Practitioners in the field comment its insect-inspired swarm intelligence, its resilience, decentralization, and ability to self-repair and experience complexity problems, overcome them. Arguably, applications seek to emulate informality to capture the capabilities of situated, decentralized insights, heterogeneous forms of knowing and sensing or touching, and tactile, agile intervention. The tendencies toward decentralization and centralization are combined and organized through what Parisi has called parametricism, the construction of relation between various variables, data sets, or sources of intelligence by assigning numerical weightings. And this process can be automated in machine learning. Parametricism is fundamental to computer modeling to make connections between various factors in algorithmic computation. So, for instance, IBM has recently developed a comprehensive analytics tool we call the reuse selection tool. And it combines product engineering and material data, modularity and reuse potential data, regulations and financial data, such as market price and costs of remanufacturing, and supply and demand data at various product taxonomy levels. All these data sets can be integrated into a single model by means of parameters, indicators that correlate different databases and different variables, thereby establishing connections across heterogeneous, local, decentralized forms of intelligence. And as models become increasingly complex, parameters are, and I quote Parisi, evolutionary variables that enter and exit relations with other parameters. They form the programming capacities to, and I quote again, calculate potential conditions of relationality and change. Yet parametricism in AI produces uncertainty, contingency, and liminality, emerging from and imminent to its operation. AI modeling abides by what Amor has labeled almost seeing, namely a speculative mode of producing actionable knowledge. Its goal is to approximate beyond the limit point of measurement, the very modification of the unexpected future. Such parametric modeling regimes are designed to incorporate uncertainty, making calculations of imprecise probabilities possible exactly at the point at which traditional knowledge production is arrested. Speaking to the breach in conventional standards for knowledge, the Ellen MacArthur Foundation warns that an obstacle to the circular economy is that regulators will be suspicious of algorithms that offer probabilistic rather than certain knowledge. Yet uncertain correlational knowledge is precisely how machine learning artificial intelligence algorithms work. Now, as I said in other papers, I have looked more at the specific technologies, but we'll skip that now. I will rather offer a more like roundabout idea about what this does, following Parisi. As Parisi sums up, indeterminate data and speculative AI gives rise to spatiotemporal events, which arrive and perish without constituting a continual surface. So rather than the smooth modulations of control, at stake is, according to Parisi, and I quote again, the calculation of complexity by complexity, chaos by chaos, an immanent doubling infinity or the infinite of the infinite. Parisi's insight implied that modeling in a circular economy produces its own circuits of data that inform speculations and interventions that give rise to new actualities, which produce more data and more interventions, constituting a viral circular economy, if you will. If the AI-enabled circular economy, in fact, does not offer transparency or control, what happens to responsibility? New materialists have problematized anthropocentric accounts of agency and humanist models of responsibility. Ned already alluded to this. So often cited, Bennett argues that our assembled agency leaves us never fully responsible for its effects. And she takes issue with blame politics because the entanglements of persons and things implies that individuals and by extent corporations are, and I quote, simply incapable of bearing full responsibility for their effects. Bennett's points can be applied to the assemblage of waste, matter, and flows that combines with AI. It problematizes waste activism that often deploys mapping and tracking in the name of transparency while targeting the big corporations and using the force of the brand to hold them responsible. So also my own desire to see waste, right, that I initially had. This much restricted notion of responsibility might, however, find an unfortunate parallel in discourses around AI. In the context of AI, claims of high levels of accuracy and objectivity, tell Campolo and Crawford us, coexist with claims that place AI beyond responsibility and liability. With regard to e-waste, the irresponsibility of the informal milieu might be replaced with a new form of irresponsibilization. However, more in line with new materialist takes, my point is not that we should be less speculative, or that we should go back to notions of human mastery, which partly informs corporate transparency and responsibility notions, as well as the activist discourse. Instead, we should be more speculative and expand the speculations regarding waste that are currently excluded from the speculative yet nonetheless particular cases avoided by AI-enabled logistical media. So for instance, here you have a Apple corporate responsibility report that really alludes to this idea of like transparency and giving data. So for instance, how do you even break down the destruction that e-waste triggers? Do numbers sum it up? Are we on the right track in fighting environmental depletion? Now we know that from 100,000 iPhones, Apple has retrieved 11 kilos of rare earth material. So that's the claim Apple gives here. How to even express e-waste impact? Where, for whom, for how long, with which degree of indirect ramification and complexity? So if we need to be more rather than less speculative in our approach to the circular economy, is there another way to deal with uncertainty, contingency, and liminality? In similar vein, Wendy Chung embraces rather than condemns uncertainty as part of climate change modeling, arguing that, and I quote, "We need to address uncertainty as enabling rather than disabling in order to reconnect AI-enabled modeling, situated embodied experience, such as like the sense and touch of waste, for instance, and political action." Bringing me back to parametricism, she raises questions such as, how are we to consider the relation between correlation and the future, not to shut down the future, to shape it into what it is most statistically probable, but to deal with invisible forces that we cannot entirely know, but need nonetheless to change? So drawing on this, would a more ethical feedback loop be possible for the circular economy? One that senses harm, redistributes responsibility, so responsibility, and opens up alternative future for waste, beyond the seriality of gadgets that are launched on the market. And I have been part of, I've been trying to work with students on a project. We're just waiting for the pandemic to subside and campus to be full of students again. We have developed an open repair app that allows, or web service that allows people to work with the repair. And hopefully, this is another take of a circular economy. It doesn't answer the questions that I just raised about another type of feedback loop, but it is a little experiment in connecting people and matter in different ways. I'll stop here. Thank you.
Well, thanks very much, Rolien. It was really fascinating to see your paper then alongside Mark's, and we'll be looking forward to unpacking these relations soon, I'm sure. So our next speaker is Orit Halpern. It's a pleasure to introduce her and welcome her to this event. Orit's an associate professor in sociology and anthropology and co-director of the Speculative Life Research Cluster at Concordia University. And over to you, Orit.
Thanks. And first, thank you for the invitation. It was amazing being here, and also a real privilege to come after these two amazing talks by Mark and Rolien, who hopefully, actually, I'm talking about resilience, which will speak, I think, to some of these themes about pandemic to endemic, but also about the management of uncertainty and maybe histories of epistemology. I have to apologize. I thought this was at 9 p.m. my time. So I got hauled on here 2 hours earlier. So this might be a little not as perfect as usual, but let's try, and hopefully I won't run too long. I'm gonna share my screen here. So I'm sure you're all familiar with this chart. Today, in the midst of the COVID-19 pandemic, the term "a new normal" has been circulating ad nauseum through news outlets and social networks. The new normal is largely defined by a naturalization of precarity for some and endless profit for others, and endless data curves and data visualizations show us these truths. It's hard to gaze upon these curves and not be reminded of a history of actuarial practices involving populations and race. And our adherence to the normal for me is often, therefore, also about nature, of course, in quotes. But what form of nature is this? My intent is to briefly historically situate this new nature. Few images today are more prevalent, of course, than flatten the curve. Maybe not now that there's a vaccine or what have you, but and for our purposes, however, what I'd like to think about in Flatten the Curve as a discourse is that it has some curious features. And of course, there's a history to this curve and you can ask me about it. But for now, I just want to isolate some key ideas about it. And among them is the assumption that pandemics are inevitable and that there is uncertainty as to when and where they will start. Public health officials have long warned of coming pandemics. There's a large literature to this effect. There's, however, no agreement as to the exact moment of the outbreak or the specifics of the disease. Pandemics are clouded in certainty, but still demand to be managed. They are, in short, known unknowns. Furthermore, the discourse assumes that the emergence of new diseases is difficult to entirely mitigate. While public health professionals and many others fully understand that better urban planning, social equity, and public health infrastructures, transforming agricultural systems, improving environmental management, et cetera, and many other factors might change the inevitability of future pandemics, almost none of us actually believe the necessary infrastructural changes will happen that could save so many lives. As a result, we must manage this uncertain event, ergo flattening the curve. In that COVID-19 spreads through breath and life, we have to slow the metabolism of the system to accelerate the demise of the virus. This is the management of temporalities, a strategy that assumes catastrophe will occur, but that there are ways to treat this trauma. And I'm going to discuss these forms of management today. Volatility and uncertainty, however, were not always considered norms of nature. Since the Second World War, cybernetically informed ecologists had built models that understood the word in terms of homeostatically organized network systems. Initial models grounded in communication sciences and tested on the landscape of nuclear blast sites valorized stability or return to a previous historical state. The most extensive effort at computing the future of the planet and its populations, the Limits to Growth report of 1972, modeled, to cite Paul Edwards, such a closed world with limited resources that had to be kept in balance. But many ecologists, environmentalists, and economists did not agree with the report. Ecosystems, they argued, did not appear to stabilize after suffering disruption. There would be no going back historically to a less damaged planet. DDT, Agent Orange, and many other situations demonstrated wide and systemic impacts. Even efforts at sustainability were often discovered to be incapable of returning systems to past states. Increasingly, the verdict was out that nature appeared to constantly be evolving. At the forefront of this discourse was economist Friedrich Hayek, who attacked the Limits to Growth report upon receiving his Nobel Prize. He pleaded for the global community to refute such certainties and imaginaries of control over the future. Hayek and many other economists and engineers questioned the assumption that the world could just evolve without change. Do not, they asked, humans learn? And what about technology? Hayek stated, and I quote, "Man must guard against becoming an accomplice in man's fatal striving and control society. A striving that makes him not only a tyrant over his fellows, but which may well make him the destroyer of a civilization which no brain was designed, but which has grown from the free efforts of millions of individuals." Hayek posited a world full of uncertainty and chance. Unable to predict the future, we should relinquish planning for management, assume that societies like ecologies emerge from decentralized networks of coordinating information through markets, and refute the possibility of regulating the economy. Systems would self-organize from the free effort of millions, not the conscious decision-making of a few. And in some of my other work, I kind of trace the relationship also between Hayek's notions of cognition and Frank Rosenberg and the history of perceptrons, and sort of our thinking also about the way artificial intelligence and big data systems operate. And control understood here is the prediction of the future. And these new ideas of nature came within a context where older models of political economy were also in flux. The end of Bretton Woods, decolonization, post-Fordism, and the OPEC oil crisis, to name a few of the transformations at the time, induced extreme volatility in politics, currency, and commodity markets. In 1973, the now infamous Chicago School economist Milton Friedman announced, and I quote, "a major need for a new broadly based, active, and resilient futures markets." A new language had started to emerge, one of resilience. Published an important article, The End of Bretton Woods, An Opportunity for a Vibrant Futures Market in Currencies, Friedman laid out the vision of the future of the world's currency markets. He argued that the end of the gold standard provided a previously unforetold opportunity. This new volatility would not mean instability, but rather opportunity. The opportunity was responded to with derivatives. The question ecologists, economists turned to asking was, if prediction of the future was impossible, how are their models failing? And more importantly, how can these seemingly unanticipable events be dealt with? How does one manage for radical uncertainty and change? And the answer, they argued, was to begin hedging their bets. Derivative pricing equations were the response to Friedman's call. In finance, a mode of managing time may be metabolism in a world understood to be constantly volatile. But perhaps no field, and here I'm showing you a chart from a very famous article from the History of Ecology, Hoyng's article on introducing the idea of resilience to ecology in 1973. The ecologist C.S. Hoyng introduced a new concept, and he opened this pivotal article, Resilience and Stability of Ecological Systems, with this argument that individuals die, populations disappear, and species become extinct. This is one view of the world, but another view of the world concentrates not so much on presence or absence as on the number of organisms and the degree of constancy of their numbers. These are very two different ways of viewing the behavior of systems. Essentially, another rebuke to limits. Hoyng posited an alternative world, not a world without change heading towards catastrophe, but a world where change, even catastrophic, is the norm and heralds not the end of systems, but evolution. Extinctions happen, but systems, degrees, and evolution continue. And Hoyng developed this concept of resilience to contest the premise that ecosystems were most healthy when they returned quickly to an equilibrium state after being disturbed. His argument was that overemphasis on predator-prey relationships often ignored more complex interactions and overvalued equilibrium. And it happens to be that these are also the first like GIS and CGIS mappings. You see here, this is actually densities of budworms in forests in southern Ontario that have been topographically mapped to show the kind of variations happening between these two species. But his argument is that we focus on very specific types of relations, thus ignoring the complex set of relations. And what we need to measure now are relations. It's not the number of species, it's not the number of animals that are living or dying. It is rather the relationships between those animals and the kind of services or functions that an ecosystem provides that need to be maintained if you're managing an ecosystem. So nitrogen, carbon, and other cycles, interactions of mutual aid, collaboration, or competition between many species, not structured as predator-prey relations, and a myriad of other factors need to be focused on and might permit ecosystems to preserve in their functions, even if in mutated or varied forms. So extinction in this case might not be the limit to the growth or change of a system unless it fundamentally transformed a complex web of all the interactions. The seeming absolute limit to life, extinction, in these kind of models could be extended through complexity and a new value for biodiversity. So, and I'll talk a little bit about that. So sustainability was the language of stable systems in a cyclical economy. Resilience is the language of volatility. So managers, he suggested, must cease counting and taxonomically placing populations in boxes and flowcharts and needed to instead realize that positive feedback is dynamic and produces change, and populations are not static numbers, but ongoing processes. And it's the process you maintain, not the individual number of animals. So you could lose like one species in an ecosystem, but as long as the larger web is kind of structured and maintained, you might be okay. The important thing is to maintain the process, not just a steady state of the system. So there's three summary points I want to underscore that emerged out of this. And you can ask me a lot more about the specifics, but for lack of time, I'm kind of running through this. The first is that resilience within this genealogy assumes uncertainty and volatility as perhaps normal conditions. Stability and resilience, according to Hoyng, were not related. So stability is actually the counter to resilience. Stable systems are too static, they can't adapt to change. As a corollary, the life and death of individuals or even populations is secondary to the ongoing evolution of the system. Second, resilience was a new way to model systems and therefore measure them. Instead of taxonomy and organizing populations into stable categories, one had to define systems in terms of processes or relations and measure the relationships between populations and potentially other factors, nitrates, carbon, energy, etc. A corollary of this new approach is that past data can be used to build concepts, but can never actually predict the future. So there's an interesting kind of problem inside. These are largely data-driven practices. These, for example, are some of the first uses of GIS that kind of pioneer this kind of big data approach to kind of quantifying and measuring environments and relationships. But at the same time, there's this fundamental leap that always assumes that you need more data for better understandings of the system, but at the same time, that data can never actually perfectly predict the future. That data can build concepts, but can never actually predict. Probabilities have to interfere. These ecologists actually talking about that. Finally, ecologists emphasize that one of the ways by which you allow more potentialities is you have to have heterogeneity or diversity as important to facilitating resilience in a system. So systems without a surplus of functions and populations could not adapt. Perfectly optimized systems, in short, would collapse when change happened. And this is an interesting counter-understanding resilience that we might think compared to the resilience of, say, a Milton Friedman or Friedrich Hayek. I'm kind of interested at these multiple understandings of ecos that are emerging at the same time, as well as management of uncertainty. Resilience thus possesses some curious features. On one hand, the focus on processes and what we are labeled ecosystem services means that some lives and populations are acceptably sacrificed as long as the system continues to operate, and trauma is a regularized and normalized event. On the other hand, environmental managers recognize that only systems with robust diversity, redundancy, and supplemental capacities might survive abrupt and catastrophic events. Resilience fluctuates between the two poles of Darwinian evolutionary theory, survival of the fittest, and the necessity for variety and diversity within and between populations to allow for adaptability. Perfect optimization might come at the cost of low adaptation. Managing for resilience also vacillates between other debates evolved in evolution, nature, or nurture, except that this has been reformulated now into a discourse of code and context. Do you focus on the singular genome or the entire landscape of biodiversity? The term allows both understandings to advance. This brings me back to our present and our curves. In the early 2000s, following 9/11, the 2008 financial crisis and climate change, resilience has taken on a central discursive place in fields ranging from business management and logistics to psychology. And I might also say, I didn't talk about design, but it shapes a lot of urban planning design of systems like Rolien was talking about, and also that Mark was talking about. It's a very prominent discourse in many fields. Adaptive management, business continuity management, and climate resiliency planning all emerge from this genealogy, and many related terms are the direct outgrowths from ecological resilience. A search online for results in the time of COVID-19 reveals a massive number of articles, websites, and consulting services dedicated to logistics, psychology, and community activism. For managers of supply chains and corporations such as SAP and IBM, resilience is what corporations must do to ensure business continuity. Just-in-time manufacturing is now just in case, and corporations are urged to increase their options to diversify supply chains geographically and begin thinking about plasticity in manufacturing infrastructure, being able to make, for example, alternative products in different geographies. So there's also geographical relocation. We could talk about that because I was really interested in that discussion, Rolien. And to identify vital services and processes ahead of time. For the Trump administration and much of the world's leader, resilience is a call to expend populations they do not value, the elderly, people with underlying health conditions, people of color, in the name of saving the economy. Resilience thus becomes a mode of naturalizing violence for the right. This violence is naturalized through uncertainty. There's a crisis of evidence and objectivity that the right has now captured to attack the possibility of planning, regulation, or legislation against disease or to defend diversity. On the one hand, the uncertainty over the future of the pandemic becomes cause to do nothing. We don't have enough data to make a decision, or data, since it's not perfect, cannot perfectly predict the future, is flawed and invalid. In this case, certain corporate and governmental institutions become, to use historian of science Naomi Oreskes' parlance, merchants of doubt. They profit off the uncertainty inherent in complex systems and have made this uncertainty an economic and political strategy to legitimate their actions or lack thereof. On the other hand, as public health ethicist Nick King has noticed, there's a politics of evidence at play in COVID-19 responses. In the US, President Trump has made a career of critique of real elitism and a general attack on scientific forms of evidence and evidence-based decision-making. The uncertainty in this case within scientific forms only facilitates the legitimacy of his critique and allows the right to transform the catastrophe into a war of ideologies, to which Trump answers with authoritarian confidence as the best and most valid voice, while simultaneously invoking the concept that some people should be sacrificed for the economy. However, might resilience not also have some positive connotations or a faint messianic capacity to invoke Benjamin? And also this recalls Rolien's final conversation about how do we think about a politics of uncertainty or a productivity around uncertainty. Recent events have highlighted other comprehensions of resilience. For people on Earth, for many people on Earth, trauma has long been a norm, but the future should not be the same. On the Black Lives Matter website, resilience is imagined as an alternative, possibly, and I quote, "We affirm our humanity, our contribution to the society, and our resilience in the face of deadly oppression," end quote. The race theorist Kara Killing has recently argued for resilience, or citing Nassim Taleb even further, anti-fragility as a figure of thought for Black liberation, the possibility of getting stronger through ongoing shock. This is not a concept of shock that legitimates the sacrifice of lives, but one that recognizes that for Black humans and many others, trauma has been ongoing, has been continuous, and can be survived. At the center is an argument that shock may make one stronger, but resilience always admits to our ecological relations to others, the necessity for diversity, and the possibility that the future of the system will never be its past. Resilience, we might recall from ecology, demands change and diversity. And here we have to contend with how we understand evolution and genealogy. And so while I admit that this has probably been a bit of a deviation, one of my key concerns actually in engaging with AI, which is a large part of my regular research, is actually thinking about the models of evolution and change that we actually automate and indoctrinate into our systems. And so I've been really interested in trying to broaden that conversation into a bigger discussion about what resilience might mean and how it's shaping our future imaginaries. Thank you.
Super wonderful. Thanks a lot, Orit. It was really great to get this. Yeah, well, you're always fast to get this, you know, historical kind of take there that plays really interestingly alongside Mark and Rolien's papers. So, you know, I think we just go straight into questions, right? Because it's 12 past, and we try to finish these on the half hour on the bottom of the clock. So would anyone like to lead with questions? Please jump in. Or I'll warm things up a little bit. You know, Mark, what I found striking about your talk was, I guess, the kind of totalizing logic or premise behind granular environmentality, this continuous monitoring. And, you know, I found that very interesting set against Rolien's paper, where I was reading her talk there as one that was sort of talking, particularly with the example of the informal circular economies, as you know, a kind of case for the proliferation of codes, rules, practices, modes of knowledge. And then kind of Orit straddled the two. You know, for much of her talk, we got this historical contextualization of the emergence of new forms of modeling, of knowing the world, and the kind of limits to that, but the way it sort of asserted an authority, as we know. And that really kind of came through by the end of your talk, where you're making the case for this genealogy, right, of knowledge that stems back to this, you know, period of sort of dramatic transformation in post-war cybernetics, Bretton Woods and so forth. So in a way, Orit offers a synthesis of, you know, the two positions that you were both articulating. I wonder how you kind of might respond to that, each of you. Okay, let me name names. Let's go backwards this time. Orit.
Thanks for that question. Actually, I was kind of thinking about this a lot, and totally stimulating. Well, one thing is that obviously, I was actually kind of pointing very specifically to the 70s as this interesting epistemological moment. And one of the things I thought really comes together is this kind of new concept of an epistemology of uncertainty that both fuels the kind of granularity that Mark is talking about, because you kind of always see it, like one of the ways you manage not being able to see or comprehend the entire system, and the fact that you can't fully predict the future, is that you continue to kind of address things through these incredible increments or ever more refined data collection systems. But also one thing I got about his granularity was sort of the becoming ecological media, or what have you, the environment becoming itself a kind of milieu for computation, a resource for computation, and particularly the idea that relations and processes are what you're actually trying to get at through that granularity, that you're really not interested in just how many people, it's how far they are from each other, their behavioral set relation to others, etc., which for me is very much the kind of move you see in ecology and kind of data collection already at a previous time. And we could extend that actually if we wanted to think of a more global south, like the kind of things that are happening in like international development. There's all these places where people really developed extreme amounts of self-monitoring and quantification of relational behaviors and environments. And then I really saw that linked also to Rolien's concept of the way that the environment becomes calculative, and also kind of a space of predictive analytics. And I didn't talk a lot about it, but there is something always future tense in a system in this kind of forms of understanding that we don't know the system fully, but we're always going to try to speculate on its future. So I don't know if that's like an answer, but I'm particularly interested in the way people mobilize uncertainty as a resource, starting in the 70s, and like actually reorganize their financial instruments, reorganize their ecological and environmental management systems, which is sort of what I heard in Rolien's stuff too, like that we can use these new adaptive management strategies and kind of predictive modeling to sort of produce these perfect circular economies that make the environment that turn everything into a possible resource, that there's no waste or supplement to that. So I don't know, that would be my answer. I kind of see a joined kind of epistemology, for lack of a better word, that reorganizes practices.
Yeah, great. Yeah, Rolien, how would you kind of see that?
Yeah, I think that I want to point to the ambivalences in the discourses around formal circular economy, where on the one hand it is indeed about this like perfect circularity and like a kind of totalizing force of preemption that then makes every item of waste into another product. But on the other hand, I wonder whether this is a kind of like the promise of AI, the promise that never has to be fulfilled because it is always in the future that AI will function as such, right? And what at the same time happens at the moment is that the uncontrollability of waste flows and waste matter is also accepted. So that is kind of like closer to this idea of some kind of like volatility as basic condition or so, as standard condition, and it's naturalized, it's normalized, and the way in which AI functions to maybe even sustain the chaotic element of waste when it's, or waste matter and waste flows when it articulates with data, in the sense that, following Paris's understanding of the production of uncertainty and production of contingency through these systems, that is of course not part of the picture. So like translating that into a little bit more concrete terms, I'm thinking about like, how all these circular economy technologies also instigate actually the logic of planned obsolescence, or the logic of sped up consumption, because there's tracking of users and their behaviors, and everything is supposed to kind of like then produce intelligence that helps repurpose existing devices or existing matter that is now waste. But at the same time, you can see it as like a process that it in itself creates more waste, that creates more and newer like actualities, as Parisi names it, that are again beyond control. And it speeds all these cycles up to the point that actually this perfect circularity is maybe doesn't come into being, but it is the promise of AI to produce perfection that is always like a future promise. So I would like to think that the ambiguity there of the formal circular economy discourse and its relation to AI.
Yeah, I mean, a future promise that nevertheless has immediate substantive effects. And I guess, Mark, you were really kind of driving that point home quite strongly.
Thanks for that question. Thanks also for those amazing presentations. This has been so interesting. I guess that tension that you identified, what's interesting to me, and it comes across, I think, in both Rolien's and Orit's presentations, is the kind of productive character of the tensions that they both described. Or maybe I'm thinking with respect to Orit's presentation of the productivity of, the stuff that I'm looking at is really, it's commercial discourses that are really framing this promise that Rolien talked about, of kind of, with just more data, with just more information, we can get to this level of control. And Orit's observation that's actually impossible. That's not how these things work. Becomes a part of the productive dynamic there, right? Of the constant incitement, for more information, faster, better, which I suppose has that strange paradoxical logic also of the derivative that Orit talked about, which seems really interesting to me. On the one hand, risk is kind of hyper profitable, can be leveraged, around volatility. All of the things that we've been following, we know that the investment banks have been doing really well in the wake of the pandemic because they make money off of volatility. Combined with the proliferating mechanisms for managing risk and assessing risk and eliminating it, right? So this kind of combined tension or contradiction that seems to drive. I kept trying to think in Orit's presentation. Where would we locate the system? Capitalism, contradiction. At which level would we want to put it? But one level just seems to be this kind of self-reproducing set of contradictions that keeps driving the machine. I don't know. That's a quite abstract answer, but sparked by the presentations.
No, look, thanks a lot, all of you. It was very, very interesting to hear these further reflections. We've got our first question, and it belongs to Sai Tafel. Great to see you here, Sai. Would you like to give the abbreviated version of that? And we've got, by the way, about 7, 8, 10 at an absolute stretch minutes left. So I think we'll need to kind of be more machine gun-like from now on. Well, yeah, super. Here we go.
Kia ora. Thank you for a wonderful set of presentations. The question I had was for Rolien, and it speaks to some of this discourse about the circular economy, which tends to be quite technocratic and depoliticized. But a lot of what you were discussing in terms of more AI, more technology, more data, more machine learning speaks to the ideology of growth that sits behind all of that. And so my question is, how does this notion of a society and an economy that's based on growth speak in a perhaps tension to these ideas around the circular economy?
Yeah, hi Sai, thanks for your question. I absolutely agree with you. I mean, I do not have the empirical data to back up the and it's also a difficult comparison, because how are we gonna calculate the ways in which the formal circular economy as it is functioning at this moment is actually contributing to growth, and to growth that is still at the expense of the ecology. I mean, you would need to have another kind of model to calculate and prove this, but I do agree with you that indeed this entire turn to AI is actually in order to make consumption and growth supposedly compatible with sustainability, whereas I think that recycling itself produces more waste, and recycling that is AI enabled produces more contingency and less control. So I mean, I cannot make an empirical argument because I think it would be very difficult to build a model for that. But I do think it's important to understand that in the end, the circular economy is an economy in in the sense of, okay, things are as in an economy circulating, but there's also still a business model, and it is intended to prioritize ways of finding profit. So, for instance, finding profit can be through control, but finding profit can also be through this logic of the derivative and hyper speculation and so on. But this is what Mark was just talking about. The exploitation of risk, basically, and the exploitation of uncertainty, which is, you know, like in the context of waste, you can only make a whole lot of money out of waste if it's first valueless, you know. So you kind of like need that redundancy to retrieve value at maximum capacity. So yeah, the different ways in which profit is possible here are not necessarily aligned with like a truly ecological notion of sustainability. I hope that helps.
Okay, this is when we almost enter the kind of game show closing minutes before the next round of advertisements kick in. And we have two questions that I'd like to take together in really short form, if possible, from Asha and then Svetlina. And we'll see how that lands us with time. So Asha, would you like to go for it?
This is just a question for Mark. I was wondering if you're researching resistance to facial recognition technology in your project. I'm interested in ideas around agency and data, and I was curious on your take on that.
Thank you. And sorry, just before you answer, Mark, we'll collect Svetlina's as well, so we can kind of bring these together.
Hi, sorry, it might be like very weird question, but Orit, the previous seminars were also talking about habits and patterns of behavior, which I found really interesting. And I wonder, so if you're talking about resilience is not coming back to normal, so I guess that means there is no idea of reproducing behavior or reproducing some kind of relations. So how do you define a system if there is no idea of reproducing some kind of behaviors, roles, and patterns of behavior? If this is what it means, like at what time does mutation become a system?
Okay, very nice. So Mark and then Orit would be great.
Sorry. Thanks for the question. Yeah, I've spent some time looking at these strategies for resistance, and you know, some of them follow the interesting logic that we've been talking about, which is a kind of generative logic. You know, there are a range of kind of performative responses that are meant to draw attention, I think, to the use of the text. So the artworks that you know, the facial design, or the, you know, mold that you put on your head to thwart facial recognition software. I think all of these have really are not, I don't know, the way I'm reading them is they're not so much meant to be practical forms of resistance as they are meant to be attention generating exercises to direct our thought towards what it means to implement biometrics at a distance. Of course, there are some practical ones that we have been hearing about, and the ones that I think about, you know, most recently are mask wearing, and you may have seen some of the coverage of this, you know, in the Hong Kong protests, the wearing of masks, and also the thwarting of the technology with laser beams. Of course, the tech has been working to circumvent this, right? So it's that constant process where, you know, now a series of facial recognition companies claim to be able to collect identificatory information just from what's visible above the level of the mask. But also the big thing in the trade shows is multi-factor analysis. So, or I can't remember what they call it, whatever it is. You know, so we're going to combine face information with gait recognition, and what other forms of biometric information that they can gather, so that you can kind of triangulate in terms of identification. In terms of resistance, I think it's also, as is often the case with surveillance, you know, that logic of turning it back, right? So you may have seen there was somebody in Portland who realized that the police were covering their badges. And so he developed a facial recognition technology system that would enable identifying the police who were masking themselves or covering their identificatory information. My general take on that is I think there are lots of avenues for intervention. The ban, it's been interesting to me that concerns about mobilizing concerns around bias have led to the bans in many jurisdictions of the technology. But again, that has a generative logic to it, right? It sets as a condition for widespread implementation a higher threshold of accuracy in some ways, or at least of proportionate accuracy across areas. So it can become hypergenerative in terms of developing the technology. I think so much is going to depend upon the control and management of the infrastructures, which tends to disappear from a lot of the discussions. But I think that's where a lot of the attention needs to be placed. So, sorry, there's a lot to say about that, but some reflections on it.
Yeah, no, thanks indeed. We could probably talk for another hour, I think. Yeah, so Orit, if you'd like to close us out before Gay joins us at the end.
Great. So thank you for that brilliant question. I don't know if I have a good answer, but two things. First, we kind of discussed, Mark has mentioned it, it was just asked Rolien about this kind of question of how do you have a zero perfect circular economy and no growth, and within a system that believes in growth. And there's these similar tensions. What intrigues me is first where we cite the problem, and that keeps moving historically speaking, and then second, how those tensions are actually places that kind of mobilize more computation into that space or calculation. But within ecology, certain forms of ecology, I should also say these are some people, not all of them. There's millions of schools. I think that for them, there are processes that are consistent, but it doesn't mean that they'll necessarily go back to being that after a massive disruption that you should necessarily, like, let's say you have a mine and you're reclaiming it. You shouldn't necessarily be trying to go back to the boreal forest that was there before. You might not be able to. There's too much damage to the environment, and you have to try to think what you're gonna put there instead. That there has to be a constant idea that you can't just keep the numbers of populations constant. That's their idea. So I think they do have an idea of consistency, if you will, habit in operations, but not necessarily consistency in the older terms of specifically the number of animals in, or the number of species inside the ecosystem. So it's kind of switched where they see habits or what you're trying to preserve, if you will. And also the definition of the system. The system gets defined. What's a forest? Well, a boreal forest has certain constitutive elements that are different than a tropical forest. And those constituent elements are what characterize the system. And they characterize that as operations. It has certain fungal, certain nitrogen fixation, et cetera, et cetera. So.
Yeah, thanks.
I'll end there.
Great. Now, now, Gay, it'd be lovely to hear from you as we wrap this up.
Oh, look, I'll just sort of thank Mark, Orit, and Rolien for 3 extraordinary papers, really exploring the complexities of circulation, circularity, resilience, and regeneration. I mean, really amazing set of connections between your 3 talks, and incredibly provocative. So thank you so much for contributing to this panel, but I also just want to wrap up the whole series of Contagion Design and thank everyone that's contributed. It's been an amazing selection of papers from all around the world, international, national, and within the ICS. It's been an example of the generative possibilities of distance and the digital, not without a few hiccups, but a wonderful set of connections have been made intellectually and spatially. I also want to thank the audience for the wonderful questions and engagement with these talks and panels. And of course, I want to thank my colleagues at the ICS, our professional staff who have done an amazing job in making everything flow so smoothly. But also to Ned, my collaborator here. It's been a pleasure working and thinking with you, Ned. these talks will be available on our website fairly soon, and they'll also become a book in the Open Humanities Press series. So thanks everyone, that's a wrap. We really appreciate everyone's contribution. It's been wonderful to think with you all. Thanks a lot.